Alright guys, so in this part we're going to talk about the idea of combining like terms. Again, this is going to be part of the simplifying process, so whenever you get simplify as an instruction, like here, simplify the expression, you're going to be looking to do this process. So you want to combine like terms. We know what a term is already. So when you combine like terms, you're going to either add or subtract coefficients. Remember that word. So we're going to add or subtract coefficients. When we do this, we do not change the exponents. So when you guys are going to combine like terms, by adding or subtracting, the exponents stay the same. You do not change the exponents. Also, like terms must have the same variable, so it should be the same variable, same letter if you will, and the same exponent. What that means is for terms to be like terms, for example, if I had x plus x squared, notice how here I have two terms. The x is a term, the x squared is a term. Now, do I have the same variable, the same letter, x and x? Yes. But do I have the same exponent? This is going to be a 1, this is a 2. So because the exponents are not the same, these two are not like terms. And if they're not like terms, then I cannot combine them. They have to stay separate. So that's going to be our goal here, is given some expressions, which are these here, you want to try to combine like terms and simplify down to make it as small as possible. And then once you can combine, you're done. So for example, example F. Here I have three terms. I have 5a plus 2b plus 3a. I have three terms. Now, do I have like terms? If you look carefully, I'm going to have an a term and an a term. So 5a plus 3a are like terms. I can combine those into basically 5 plus 3 is going to be 8a. And then this 2b comes down to the right. At this point, I've combined 5a and 3a to make 8a. Can I combine 8a plus 2b? Are a and b the same variable? And because they're not, then at this point, I'm done. This is my answer. Remember that this is not solving, this is simplifying. So you're trying to make it as small as possible until you can't go any smaller. Just one more example. Let me show you, I'm going to bookend this. So let me go to example J, which is here. So again, in this case, I have more terms, so not a big deal. I have a 6x, a minus 7 constant, a plus x, a plus 5, a minus 2x, and a plus 8. So I have 1, 2, 3, 4, I have 6 terms. The question is, are there like terms? So I'm going to go ahead and identify my like terms. First, I see a 6x, I see an x, and a minus 2x. Please do not forget, this minus sign is attached to this 2. So it's part of that term. Do not forget the sign to the left of the coefficient. So in this case, I can combine 6x plus 1x minus 2x. Or in other words, I can say 6, oops, sorry, wrong one there. So I can say 6x plus 1x minus 2x. That's all going to be 6 plus 1 is 7. 7 minus 2 is 5x. Notice how I did not change the exponent. So I didn't make this into a cube or a little 3. I leave the exponent the same. Next, I scan again, and I see a constant. So this is just a number by itself. Another constant, and another constant. Constants are also going to be like terms, so I can combine those two. So in this case, all I got to do is say minus 7 plus 5 plus 8. And if I do that, I get a 13 minus 7 is going to be plus 6. And from here, notice how I've made this original question, which had 6 terms, I made it much, much smaller. Now I just have 5x plus 6. To finish, are these like terms? and they're not, so that's my answer.